Hello ladies and gentlemen, in this video session I will be using my time to explain to you certain protocols using packet analyzer software. So the protocols that are chosen for this session are the Ethernet and ARP, and also known as the address resolution protocol, and also the DHCP, also known as the dynamic host configuration protocol. So the packet analysis and capture software that we'll be using is Wireshark, which is an open source software which is widely used for the analysis of packets, and this will help us get an in-depth knowledge of the operations that go on behind these protocols. Firstly, we will be talking about the Ethernet protocol. This is the most popular LAN protocol that is being used nowadays. This protocol is specifically governed by the IEEE 802.2 and 802.3 standards. The table over here shows the frame format of an Ethernet 2 frame, which is the most common type of Ethernet frame, due to it's much simpler and has lesser overhead. So this particular type of frame has the type field in it, while other Ethernet frames could have the length field in it. So the frame header is composed of the destination MAC address, the source MAC address, and the type of frame, while in the middle you get the actual payload, the actual data that's being carried, and in the frame trailer you get your FCS, which is 4 bytes. So let's talk more about this Ethernet frame in the next slide. The destination MAC address is there in the first 6 bytes of the frame. It is used to indicate the MAC address of the network interface controller that the frame is being sent to, and the source MAC address is used to indicate the MAC address of the network interface controller from which the packet originated. The type is used to, also known as the ether type field. It's a 2-byte field which is used to indicate the type of payload being carried. Some of the more famous and more common types that we may see throughout this session is in hexadecimal format 800, which is the IPv4 protocol, 806, which is the ARP or the address resolution protocol, and the 86DD, which is the Internet Protocol version 6. So the FCS is also sometimes known as the CRC, the cyclic redundancy check. Basically, at the destination, once a packet is received, certain calculations are done on the data on the frame, and if the calculated value obtained does not match with the value on this field, it means that the data has undergone some anomalies during the transmission, and this packet will be terminated. Before jumping on and finding out how to analyze and capture packets, it is useful to know how to find out the MAC address of the computer that you are using. Therefore, when you analyze an Ethernet frame, you would know whether this packet is being sent by your computer or sent to your computer. So firstly, what you can do is you can press Ctrl and R on the keyboard, which opens up the run menu, and type in CMD. So on the command prompt, you can type in the command ipconfig /all, which will show you the entire list of network adapters that are being used in the current computer. Let me just take you through that. So Windows R, CMD, press OK, enter, and then ipconfig /all. This would display all the Ethernet adapters or the network adapters that are currently installed on your computer. So you should so let me just make this a little larger for you. You can give some special attention to the media state. If the media state indicates media disconnected, it means that this adapter is not currently being used. So in my case, it's just one adapter which is being used, and it makes sense because my computer is connected to the internet by one way, not multiple adapters. So once you find out the connected adapter, it should have much more information than a disconnected adapter, like its own IP address, the lease times of the DHCP. We will be covering about DHCP in the future. The IP address of the default gateway, DNS servers. You should see a whole bunch of information with regards to your adapter. And on the physical address, which I'm highlighting now, this is basically your 6-byte MAC address. This is the MAC address of your computer. Now that I have obtained information about the network interface controller that I will be using, I can easily obtain the MAC address of it, which is in my case 020D603366.30. So this will be greatly helpful for when we capture and analyze packets in the future. So we can get Wireshark, basically you can get it started right from the beginning. So you can see that the Ethernet adapter is generating traffic. Just double click on it and it will the capture will basically start, and you will see all of this information. So basically I got a web page open over here at my case, so I can just refresh it, and as you can see, the capture is going and it's live. You can see the time that has elapsed since the packet capture started, the source IP address, the destination IP address, and the protocol that is currently being used. So for the ease of navigation, you can use this to stop capturing packets, and use this, go to the first packet and go to the last packet. So let's just go to the first packet. Since there are many different types of captures with different protocols, we can make things easier by filtering for some HTTPS messages, for instance. So we can do this by copying in TCP.port 2=443, which means if the source port or the destination port has 443 in this, that we can filter all our packets using this criteria. Enter this in and press enter, and now we will have only the packets with which has been using HTTPS. So now we can go ahead and analyze an Ethernet frame. So now we will be selecting this specific packet with the TCP protocol, and as you can see the information with regards to this packet over here. So we can expand the Ethernet section further, and you can actually see the destination MAC address and the source MAC address, and you can see that the source MAC address is actually the MAC address of my network interface controller. So this message was being sent from my computer to the server that we were trying to reach, and this is the MAC address of the NIC at the end. Furthermore, we can also see that the type is IPv4, and as previously discussed, we can see that the hexadecimal 0x0800, which actually points to IP version 4, and there is even further information about the IP version 4 protocol over here, which you can expand, and there is even more information about the TCP over here. So now we can go ahead and discuss about ARP, the address resolution protocol. The address resolution protocol, what it basically does is, if a source does not have the destination MAC address but has the destination IP address, a broadcast is sent out across the network requesting other nodes to reply if they do know the MAC address that corresponds to the IP address. So your computer also stores a table of a map of IP addresses to the physical MAC addresses in its ARP cache. So to access this, it's quite simple. As previously mentioned, if you were to go from the beginning, Windows R, CMD, press enter, and enter in ARP space -A to view the current ARP cache of your computer. So in my case, something that I can see very easily is, and identify very easily, is the default IP address of my network, which is 192.168.42.129. This IP address will make things easier for us to capture and analyze packets in the next slide. So now we will be focusing on capturing ARP packets. So first of all, make sure that the command prompt has been opened with administrative privileges. Otherwise, we will not have the security clearance to delete the ARP cache. So let's go to the search cmd run as administrator, select yes on the Windows security prompt, and basically what you can do is we can start the Wireshark capture now. Open up Wireshark, choose the interface that is currently being used, and let's minimize Wireshark for now, and we can enter ARP dash space dash D, which will clear the ARP cache. And now I'm going to ping the default gateway of my computer, which was previously identified to be 192.168.1.129. So okay, ping is all successful, and now let's just verify if the ARP cache has been rebuilt. Okay, good, the ARP cache has indeed been rebuilt now, and we can just move over to Wireshark and start analyzing ARP packets. So to do this, on the display filter, just enter ARP and press enter, and all of the ARP packets that have been exchanged will appear. At this stage, what's going on is there should be a packet with the destination of broadcast. A broadcast is being sent out since we cleared the ARP cache, and now my computer does not know the destination MAC address of the default gateway. Therefore, it is sending out a broadcast to try to get the net MAC address. And so you should see a capture over here with the destination of broadcast. And now this is certainly can be analyzed in detail. So we can open Wireshark and destination broadcast. You can just further expand on this packet, and you can see that the destination MAC address is all Fs, confirming that it is a broadcast address, and the source MAC address is equal to the one in my computer, confirming that it has indeed been sent out from my PC. And the type, as we have mentioned earlier, 0 in hexadecimal 0x0806, confirms that this is indeed an ARP packet. So if we further look on to the address resolution protocol, we can expand upon this. You can see that you can further confirm the sender MAC address is indeed my computer. The sender IP address is also, this is the IP address, current IP address of my computer, as we have found out previously using the ipconfig /all command. And you can see that the target MAC address is actually all zeros, which makes sense since my computer's NIC does not know the target MAC address. It's trying to find it. So it is at this stage, it is currently all zeros, and it does know the default. This is the IP address of the default gateway. So we can just summarize this. My computer is trying to find out the MAC address of the default gateway. It already knows the IP address. So what it has done is it has sent out an ARP broadcast. So this is basically the request, as you can see from the opcode. This is a request asking for any other networks that if they know the MAC address of the default gateway that my computer is connected to. So now that the request has been analyzed, we can now go ahead and analyze the reply that we will get for this message, basically the reply for this broadcast. Coming to the analysis of the ARP reply packet. So as you can see on this slide, you can see that right after the broadcast, we have got a reply packet, and this is the more expanded view of the capture. So we can view it in Wireshark right over here. So we can see on further expanding the Ethernet and that this is indeed still an ARP message. It has been its source seems to be from the default gateway. The destination is indeed the MAC address of my computer, and you can confirm from the hexadecimal value over here 0x0806 that it is indeed an ARP message, and it is actually a reply. So the opcode specifies that it is indeed an ARP reply. So the sender IP address happens to be the IP address of the default gateway. So the default gateway is sending to my computer. You can see the target IP address of my computer over here of its MAC address. Since I originally deleted from my ARP cache the MAC address of the default gateway, it is now actually replying to my ARP broadcast with its own MAC address so that I can make up my own ARP cache. So we can very easily confirm that. If you just were to type ARPA, we can obviously see that the default gateway address has now actually been stored in my ARP cache. And so we have through this section we have studied an ARP broadcast. The default gateway has received the broadcast and replied to it with its MAC address, which my computer originally needed, so that we can successfully connect with each other. So now that Ethernet and the ARP sections have been covered on, we will be moving on to the next section, which is DHCP.